Okay, let's start with this first monthly event of PugliaDevs. I don't want to take up time to our fantastic speakers today, so Cristiano, come on. We can explain better after your presentation what is PugliaDevs, our primary goals and so on. I first met Cristiano, I think, 2 decades ago, more or less, when he was a great software developer. Now he is a fantastic data engineer. Come on, Cristiano. The stage is yours.
Thank you. Welcome, everyone. And thanks, Marco, for inviting me. The title of this presentation is Data Engineering is Not Data Science, which is something that Marco mentioned to me. Wasn't my idea, actually. But when he told me, it immediately rang a bell in my head. Like, yeah, I think there is probably some misconception there. So it'd be nice to look into it and see whether there's actually something, and perhaps we can take this chance to let people know what data engineering actually is. So let's start. Just something about myself. I was born in Bari. I work here, so one of the few people doing this job probably from here. Started coding way too long ago on an Amiga 500, and then I've done a few things, mainly around the world of software development, web applications. And since 2021, I'm a data engineer with Infinite Lambda, where I work right now as an engineering lead, looking after a team of 5 data engineers. And so a couple of words about my company, Infinite Lambda. Infinite Lambda is an international consultancy specialized in data platforms and data transformation projects. We have offices in several European countries, plus Vietnam, a small office in Singapore now, and we have customers mainly UK, USA, and across Europe, and most of our locations. We're specialized in all the main cloud providers, and we have consultants specialized in dbt, Snowflake, Databricks, and so on, across all of our offices. So let's see what we're going to talk about today. So first of all, let's see what's the difference between data engineering and data science, because probably data science is more popular. Let's see. Then a short history of data engineering, how we came to what we have today. Then what are modern data platforms? Some real-world projects that I've been working on since I joined Infinite Lambda. What's the current job market, which I think is interesting. And my experience with data engineering, since it's a relatively recent evolution for me. And then I'll leave some space for questions. So data engineering is not data science. So first of all, I'm curious, how many people here work in IT? A few, okay. How many of you know what data science is? How many know what data engineering is? Okay, more or less the same, but I think this confirms that data science is probably more popular. So, it looks like the perception that I had, it was kind of confirmed, but when I started looking into this, is that like since the growth of machine learning, deep learning, and AI, data scientists have become superstars. They are wanted. They are the people who solve all the big world problems, whereas data engineers, on the other hand, are just the usual nerds working in a dark room doing work that nobody wants to do. But let's see, is this real? Because, as a data engineer, I'd like to be data-driven. So I looked into it, and I tried to see what are the search trends for these 2 topics. And as you can see, data science is vastly more popular than data engineering. But data engineering is growing steadily over time. But this is the search interest. So how much people are interested in this topic, not how popular it is in the job market. So let's see. What does LinkedIn tell us? In the last month, there were 141 new job postings in Italy for data scientist jobs, data scientist positions. Do you think data engineers were more or less? More. Quite a lot more, like double, more than double. So, you may want to look data engineering up more than data scientists. There's more work there. So let's see, what is data engineering? So data engineering is just software engineering, but specialized on data. If you've worked as a software engineer doing like back-end development, it's mostly the same stuff, just with much more focus on data. This is the definition that I found on Wikipedia. Data engineering refers to the building of systems to enable the collection and usage of data. This data is usually used to enable subsequent analysis and data science, which often involves machine learning. Making the data usable usually involves substantial computing storage, as well as data processing. So, see, it mentions machine learning, so our friend data science. Now let's see, in turn, what is data science? Data science is about using the data to extract information or build models based on this information. Let's see, for comparison, the definition. Data science is an interdisciplinary academic field that uses statistics, scientific computing, scientific methods, processing, scientific visualization algorithms, and systems to extract or extrapolate knowledge and insights from potentially noisy, structured, or unstructured data. But there are some touch points between the two. Whereas data science will use statistics, machine learning, visualizations, and so on, data engineers will most work with data warehousing, DevOps, and security. But both will have to use SQL to build their models, very likely to do their data analysis. They will do some programming, and they'll be processing data. So these are very much things in common. And you will see that, in fact, there's a lot of contamination between these two roles. So let's see how we got here. So during the 70s, the 80s, the foundations for data were databases and data architectures were laid. And it was called back then information engineering methodology. Then around the 2000s, data started becoming bigger and bigger. And so data warehousing was born. In 2010, internet was becoming really, really big. So having lots of data and being able to use it was the thing that gave you an advantage on the market. And so we got big data. You can probably remember it. It was all over the place. And so that's when Hadoop, Spark, and data engineering were born as a new discipline. Then in 2012, Snowflake was founded, which was a revolution. And in fact, it was a huge market phenomenon. And since then, things have been evolving so fast. And that's where we are today. So, but let's see, why did we get to data platforms? Wasn't it enough what we had before? So we started with OLTP databases, which are transactional databases that work on few records at a time, but very quickly. Whereas OLAP are analytical databases, which work on large quantities of data at once. So of course you can see that these are not compatible workloads. These two things can hardly be matched or provided by the same system, either because they won't be optimized for both or because they will be conflicting. So OLAP came. But then there's still some other problem, because if you have many systems, you will not be able to query each of them using the same language. Each of them will have their own APIs and so on. So you want to put all the data in one place so that you can join the data across several systems and gather more information, more intelligence, which otherwise you wouldn't be able to. And so that's how we land to data platforms. So today, the big buzzword is modern data stack or modern data platform or variations of it. And it's a pretty complex beast. This is like enterprise stuff. So this is Microsoft's version of it. There's a lot of stuff in there. And this is AWS's version. Again, lots of stuff. But let's cut to the meat. This is basically the main components. So on the left, you have data sources, the systems which produce the data. So your applications, all the services that your company uses that contain important data for the company. And then you have your data platform. So you will want some way to put the data in there. And this is normally called data lake, because you will basically pour all of your data into it. And then the data goes through several layers until it becomes usable by for reporting, machine learning, data science, and other applications. So let's see who takes care of each of these layers. So the first layer will usually be the realm of IT. So application developers and system management and so on. But then you need data engineers to bring the data into the first layer. You see the layer in the middle, it's in half because that's kind of contested. Depending on the environment, it may be owned by data engineers or not. Then the data is picked up by analytics engineers who model the data, shape it in a way that it's usable and useful for anyone after them. And then here we have data scientists. So you see, it's much smaller than the rest. Of course, these are all generalizations. That most of the time, each of these people will be doing more or less everyone else's work when needed. And this whole stack led to the birth of lots of new technologies, which you probably never heard of, even if you work in software. Like, I don't know if you've ever heard of Fivetran, or Databricks, or Snowflake, or DBT. DBT caught the world by storm. Now it's basically the default system for data modeling. It's everywhere. All our projects, I think, all the projects that I've seen since joining Infinite Lambda had DBT in some shape or form. So there's a lot of stuff in there, lots of innovation, so it's something to watch. Now let's see what are some real projects that I've been working on as a data engineer or a data architect, solution architect. So this company came to us with a problem. They had an open source data warehouse distributed on multiple data centers, and they could not reconcile the data and consolidate it in one place. They could not query it efficiently, and they couldn't maintain it properly. So they wanted something better. So they came to us with this need, and of course, we took this chance to also give them a number of other features. And so we designed an architecture which, with a collection endpoint, which would gather all the data from each data center using Debezium, which is a CDC platform that will basically listen to changes on a database and send them to a log so that they be consumed, and that way you can replicate the data elsewhere. So we use that to replicate the data inside the data warehouse on Snowflake, and then we also use Fivetran to ingest data from other external systems. So once the data is all in one place, then it's much easier to make use of it. So this is something that, for example, we did, and the stack was Kafka plus Kafka Connect for streaming and ingesting data, Debezium to extract the data from databases, AWS with S3 for storage, Fivetran for ETL, which is a big concept, extract, transform, load, and DBT. Let's see one more. So this company is a market leader. Of course, I can name it, but it's an old company, lots of legacy software, and they wanted to completely revamp their data stack. So they came to us with an idea, and we evolved it. And we designed this completely new data platform with streaming as a first-class citizen, and a strong integration platform as the basis of it that allowed any other new system to be plugged into it and be by default also connected to the data platform and allowing real-time integration with any other system. And as you can see, Kafka is at the core of it. And this is an example of one of the data flows that we designed for one of the entities. These are customers that coming from the customer app all the way through Kafka, then go into other systems, into the data platform, and then back to persist state where it can be consumed by the operational cache. All of this, again, Kafka MongoDB, Salesforce, Snowflake, dbt. dbt is everywhere. Now, let's say you liked it and you're curious, how do I become a data engineer? So the main skill you will need is SQL. You can see it's 79% popular. So that's the most important thing. Second is Azure, apparently, which is growing as a cloud provider. In my experience, I don't know, perhaps, I don't know, just by chance, but we most often work with AWS, but still, or maybe because this is data from the United States, where it's more popular. But in any case, I think any cloud provider, knowledge of any cloud provider is a good starting point. And then you see ETL that I mentioned before, which is bringing data from one place to another for analysis. Spark, data lakes, data modeling, and so on. Cloud skills. It's very important, as I said, to know one of the main 3 cloud providers: Azure, AWS, GCP, Docker, for example, Kubernetes, and so on. So these are probably the first things that you should be looking at. But let's see what's the market like in Italy for data engineers. So this is data that I found on Glassdoor. So the base salary for a data engineer in Italy is 32,000 per year, up to 40,000. I think this is net values, because on Glassdoor people report their salary, so it's usually net. On this other website, talent.com, it says the median is 3,500, so which is probably higher because it's gross. So it's more or less there. So it's a competitive salary, I would say, for Italy. Probably elsewhere is even higher, but you get the idea. Now, what was my experience moving from pure software engineering, the world of the web, into this world? Completely, well, not completely different, but different, very different. First good thing that I still think that I have it: no more calls outside of office hours or during the weekends because something broke. There's less competition in the market, so better pay. Less stressful environment. There's usually less pressure because of the first point. No JavaScript fatigue. I don't have to worry about new JavaScript libraries coming out twice a day. Technology is generally more stable because it's like enterprise level stuff usually. Less dependence on unstable stakeholder requirements, because usually you just need to ingest the data source. They don't care how you do it. Cons: almost exclusively enterprise environments, which not everyone likes. Work is probably less exciting because you're not customer facing. You're not at the forefront of what the people see. It's work that nobody sees. Technologies evolve slower. Less opportunity to do sophisticated development work because, of course, building data pipelines is usually just a little bit of code. You don't do very large software projects. It's more like a composition of different components. And it's harder to do testing, so the code quality is generally lower because of this. Also because it's small, people usually or tend not to bother writing tests. So it's a bit less stable, but not too bad. So this is my experience. Overall, I will say net positive. And I think, if I remember my presentation well, I think that's it. And of course, if you have any questions, feel free to shout.
I was wondering, how do we gather the data? I mean, let's say that I have an application and I want to record the user who presses one button. Okay, normally I would execute the code of the button, and then at the end of the code I would run another function for the, I don't know if it is called telemetry in this case, record that the user pressed the button. But this means that at the end of the function we might want to call other function and so on and so forth. But wouldn't it be better in this scenario to use a publish subscribe paradigm. Yes, for instance, okay, let's say that the button just runs the action, publish that the user pressed the button, and then there is a series of functions that subscribe to that event, and we have the function that executes the code of the button, or it executes the function related to the button, and then I can have other function that record that the user pressed the button.
Yeah, yeah, good question. So one of the first reasons why you normally have a data platform is for decoupling. So you don't depend on, you don't have to affect your application to extract data from it. So normally you would use some indirect way of ingesting the data. So rather than integrating directly with your application, so when the user clicks, something is sent to the data platform, you will usually have some process which reads from whenever that click is stored and it's copied into the data platform. But that's not the only solution, of course. As anything, it depends. There are tools. You could, for example, integrate with Google Analytics, or there are software like Snowplow, for example, which can track anything, basically, and then you can ingest the data into the data platform. Or you could have a message bus so that every event that is useful or can be useful will be sent, as you said, pub sub. You send it to a queue, and then whoever's interested subscribes to the queue. And one of the clients for the queue could be the data platform. So once the events are stored there, you can do with them whatever you want, and you haven't touched your system.
Oh, thank you.
Okay.
No,
it's nice to see that data engineering is easier than software development, but it's really easier and less stressful because it is a different job, or because it has a lower business impact.
So it's not easier. The code is simpler, generally, because it's smaller. A data pipeline is usually a small piece of code rather than a big application. So it's a data pipeline will just read from somewhere and write somewhere else, usually. Or even less than that. We'll just read, and then something else will take care of writing. So it's a very little code, so that's why it's simpler. But it's not an easier job, because you still need to know lots of stuff. So for example, when you do web development, well, let's exclude front end for now. But when you do like application development, you usually use a few technologies. You have one language for most of the application, then you will have one database technology, maybe you use Docker to containerize it, and Git, not much more. Whereas the average data engineering project will have lots and lots of different technologies involved, because that's basically it. It's bringing stuff together. So you will have to interact with lots of different things.
But you said lower pressure.
Lower pressure, because if a pipeline breaks, I won't be called during the night.
So it's only about safety of our job. If we can do also on software development a safe software development, it could be simple and safer and easier and less stressful than before. So the problem can be fixed also in software development.
Yeah, of course, it depends on the context. So I've worked on very relaxed software development projects because the application was internal. So if it was down, people would just do something else while I fixed it.
That's the point. Thank you.
Hi, great talk. I want to know how much. Excuse me? I'm Gaetano. I'm a software engineer. And I want to know how much percentage of low code, no code there is in your applications. And what do you think in the future will be? Thank you.
Okay. I think there used to be more no code, low code. there was I think a massive change. I don't know, maybe Gianluca can confirm. Gianluca is my colleague. DBT massively reduced the usage of point-and-click tools because it allowed using just plain SQL to describe the data, whereas previously tools where you could basically draw the ERD for the relationships between your schemas visually, but that caused lots of headaches, technical debt, people unaware of what they were doing, causing performance issues. So this plus other similar technologies moved, I think, the needle more towards engineering best practices rather than no-code tools. There are still some, but I also want to say that this may just be my point of view because of the type of work that we do with our company. So I cannot speak for the entire market.
Okay, thank you.
So, hello. I think okay, good. Checking the audio. What do you think, and when do you think a business should start considering data engineering to inform their decisions for a business? So, from terms of headcounts or GMV, when do you think that should start really mattering for a startup? At what stage?
Well, I'd say as early as possible, because the more you wait, the more expensive it will be to kickstart a data platform, because you have to build the integrations and so on. And if you do it from the start, of course, you can make things more efficient, because if you plan your application, I guess we're talking about technological startups. In that case, if you build a data strategy inside your app from the start, you can take advantage of many things which otherwise you wouldn't be able to use, or would be much harder. For example, real-time data. If you integrate, as we were talking before, if you integrate with events rather than reading from the database in batches, you can have the data in near real time available for your data platform, which also means that you could use it for other purposes, even operational purposes, without affecting your main application. So there are many things that you could do. So I would say as early as possible. You can start small using open source software, and then you can grow, you can scale up as needed. But I'd say as early as possible if you have the resources.
I was a bit late, but as I saw, it seems like you need to know a lot of stuff, like different databases, different technologies. So if I want to start like a career in data engineering, maybe it's better I start in software or in system engineering, and then I pivot. Can a junior data engineer exist, or?
Yeah, they can exist, because we have some. I have a couple in my team, definitely, but it can be overwhelming, and also it's harder to experience good engineering practices because of what I said earlier. So if you want to learn how to write proper software, how to use versioning, testing, CI/CD, DevOps properly, you need to write complex software, because otherwise you don't need to. So you perhaps won't bother and won't learn it. There's no pressure. No strong pressure to do it. There may be in some context, but in some there may not be. So I would say certainly I would start from a pure software development career and then move. I remember I was told when I joined Infinite Lambda, I was terrified because there were so many new things, and I was told, don't worry, because software engineers make the best data engineers. You'll learn fast. And now I say the same to my new data engineers. Thank you.
Thank you so much, Cristiano.